Swagatam Kapati Mathematics classes. This is your Murali. This is the 10th video on the topic trigonometry. In this video, I am going to explain you about the graph tan. How to draw y is equal to tan x graph, what is the shape of the graph, and what is its periodicity, and what are the properties I am going to discuss. Now, before going to the actual lesson, I want to introduce a very interesting word, asymptote. A word, a new word, asymptote. What is asymptote? Asymptote is a straight line. Of what? Let me explain. Let y is equal to, we have 1 over x is an equation of the curve. If you observe carefully, when I put x is equal to 0, my y is becoming infinity. Becoming infinity, not equal to infinity. When x is equal to 0, now this straight line x is equal to 0 is asymptote of the curve y is equal to 1 over x. Let me explain one more example. I have y is equal to, I have 1 over x minus 2. 1 over x minus 2. Now, when x is equal to 2, my y is becoming infinity. Therefore, x is equal to 2 is an asymptote of the curve y is equal to 1 by x minus 2. So clear. So asymptote is a straight line. How do you generate the equation of straight line? For which value of x my y approaching the infinity, that is called asymptote. Equation of the asymptote. Okay, then what is its character? Let me draw the graph for y is equal to 1 over x. Now, the graph of y is equal to 1 over x will be like this. It's not exact graph, just a graph. If we observe carefully, when x is equal to 0, my curve is trying to approach the straight line x is equal to 0, of course nothing but y-axis. And this curve never meets the y-axis at a finite distance, or simply I can say this x is equal to 0 is a tangent drawn to this curve at x is equal to at infinity. The tangent drawn to the curve at an infinite distance is called asymptote. Very simple concept. Why? Because I want this asymptote concept for the graph y is equal to tan x. Now, come to, so what is an asymptote? Let me write. Asymptote is a straight line. It's straight line. For x is equal to some k. Of course, you can have this x is equal to k is a vertical asymptote. You can have horizontal asymptote. You can have slant asymptotes also. But we don't want all those things. Simply I confirm to this one. X is equal to k. I write vertical. For x is equal to k, the curve approaches. The curve approaches. The line x is equal to k, and the curve does not meet the line x equal to a at a finite distance. Please plot it. Now come to the graph y is equal to tan x. The values of tan function for different values of x I tabulated from 0 to 360 degrees, and we know very well how to obtain these values by using all silver thickness if the x value is more than 90 degrees. So that is one lesson. Now come to the graph. Y is equal to tan x. When I substitute x is equal to pi by 2, my y is going infinity. When I substitute x is equal to 3 pi by 2, then also y is going to infinity. When x is equal to 5 pi by 2, my y goes to infinity. So in general, my x is odd multiple of pi by 2, my y is going to infinity. Where here n is an integer. Therefore, my curve y is equal to tan x have asymptotes x is equal to pi by 2, x is equal to 3 pi by 2, x is equal to 5 pi by 2, or x is equal to 2n plus 1 pi by 2 will be an asymptote to the curve y is equal to tan x. Because at these values, my tan x is becoming infinity. Okay. Now, what is the use of these asymptotes of this one? Now, let me draw that rough graph. I am not a drawing master, so I know only rough graphs. Let this equal to x-axis, y-axis and origin. I'll take pi by 2, 3 pi by 2, 5 pi by 2. Listen carefully, when you are writing x is equal to pi by 2, it is an asymptote. You cannot write this as x is equal to 90 degrees. This is a wrong expression. For all the numericals, we have to use the radians only. Please remember this one. That's why I am using x is equal to 5 pi by 2. Okay, now we have one more also, minus pi by 2. X is equal to pi by 2. X is equal to pi by 2 is a vertical line. X is equal to 3 pi by 2 is another vertical line. I'll give this some gap. Better, right? Because this much gap is there. 3 pi by 2 and 5 pi by 2. Okay, now x is equal to minus pi by 2 also is another one. Back to the dots. All these are asymptotes. To be as per this definition, my tan curve has approaches to infinity when x is equal to pi by 2. When x is equal to minus pi by 2. Now I will concentrate on 0 to pi. When x is equal to 0 is 0. When x is equal to 30, somewhere in 1 by root 3, that means 0 point something. When x is equal to 60, somewhere here. So the graph goes like this. What happens to this negative one? And you know very well, tan of minus theta is equal to minus theta, right? Tan of minus theta is equal to minus theta, so it has to come down. This is the tan graph between minus pi by 2 and plus pi by 2. Between pi by 2 to 3 pi by 2, again at pi it is 0. At 3 pi by 2, it has to approach infinity. So again the graph will be like this, infinity and coming down. The tan graph. And between 3 pi by 2, 5 pi by 2 also, my graph will be like this. Same thing, at 2 pi it is 0, so it is an infinity. Asymptote, there is a graph. If you observe carefully, the shape of the graph is repeating between two asymptotes. Shape of the graph. So the tan is also periodic function. So let me explain the properties. The graph is a tan graph looks like this, and let me explain the properties. Property means in the first quadrant 0 to pi by 2. What is happening? It is increasing from 0 to infinity. Next, between minus pi by 2 to pi by pi, it is negative infinity to 0. Pi to 3 pi by 2, 0 to infinity. 3 pi by 2 pi, negative infinity to 0. That means it's always increasing. So the tan function always increasing function. So I write properties or observations. Observations. In first quadrant, tan x increases from 0 to infinity. In second quadrant, same tan x increases from negative infinity to 0. Next one. In third quadrant, my tan x again increases from 0 to infinity. In fourth quadrant, tan increases from same negative. So always increases. Therefore, my conclusion is y is equal to tan x graph always increases. Okay, next one. So can I write this as therefore? What is the minimum value and what is the maximum value? There is no minimum value, there is no maximum value. That means tan can generate any real number. Therefore, what is the range of tan function? The tan range is a real number set. In some textbooks, they write negative infinity to positive infinity open interval. Next one. It's a periodic function, right? Yes. Why? Because the shape of the graph is repeating in the interval of pi radians. So the tan is a periodic function with a period pi. Tan graph repeats in the interval of pi radians. Therefore, it is periodic and the period is is I. So this is the observation. Tan. If you know how to draw the tan graph, drawing the chordograph is very easy. Please take care.